Very well. The third function is function involving absolute value. So number 3 is absolute value and functions involving absolute value. I'm going to give you 2 examples to see how to deal with absolute value. Number 3, functions involving absolute value. For absolute value function, always use the definition. We always use the definition of absolute value functions. Absolute value of x is defined as if x is larger than 0, it's going to be x itself. If x is equal to 0, it is 0. And if x is less than 0, you put a minus sign in front of your x. There you go. Give us an example. Example 1. Suppose question says find the limit of absolute value of x as x approaches 0. Okay, very well. We're going to use the definition of absolute value. As x approaches 0, we have 2 things to investigate. X goes to 0 from right-hand side. X goes to 0 from left-hand side. Okay, remember the graph of absolute value, V shape. This is your absolute value function. X-axis, Y-axis. So let's take a look at this. The limit of absolute value. The limit of absolute value of x. As x approaches to 0 from right-hand side, we are going to 0 from right. 0 from right. What is the y value? The y value is getting closer and closer to 0. What if I go to 0 from left-hand side? What would be the limit of absolute value? The limit of absolute value of x as x approaches to 0 from left-hand side. We are getting closer and closer to 0 from left-hand side. What is the y value? The y value is getting closer and closer to 0 on y-axis. This guy is also equal to 0. 0 is equal to 0. Yes. What's the meaning of that? It means that the limit is equal to 0. Give us another example. What about this one? Find the limit of absolute value of x divided by x as x approaches 0. Very well. I know that if I have functions involving absolute value, I have to use the definition of absolute value. X is getting closer and closer to 0 from left. X is getting closer and closer to 0 from right. So let us find the limit of absolute value of x divided by x as x approaches zero from right-hand side. Okay. Absolute value of x for positive numbers is equal to that number. So if you're getting closer and closer to zero from the right, you're going to have x. It is x divided by, we copy down whatever is on the denominator as x approaches to zero from right. Of course, you can cancel out x and x. They're the same factor. What's left? 1. Limit from right is 1. What is limit from left? So, limit of absolute value of x divided by x as x approaches to 0 from left, you're using the definition of absolute value. As we are going to 0 from the left, you write down the number with a negative sign in front of it. So on the numerator, you get minus x, the definition of absolute value, divided by whatever is on the denominator x as x approaches to 0 from the left. Well, I can cancel out x and x. What's left? The negative sign. What's the meaning of that? It means that I ended up with -1. So this is limit from left. Very well. 1 and -1 are equal to each other? No. So what's your conclusion? The limit does not exist. Does not exist. Well, what's the graph like? So for this function, if we simplify this, this is what we have. So fixed numbers, 1 and -1. From left, -1. And from right, we have 1. And we have to exclude the 0. This is the graph of this function. We have 2 line segments, and we have to exclude 0 and 0. So as you can see, the limit doesn't exist at 0. There you go. Let's talk about when we plug in a number, we don't get 0 over 0, infinity over infinity. But we get some other values like infinity or negative infinity. So when limit is infinity or negative infinity. For example, question says find the limit of 1 over x squared as x approaches 0. Well, okay. If I plug in 0 here, I get 1 over 0, which is equal to infinity. Okay, what's the meaning of that? Now remember the graph of this function. The graph of this function behaves like this. This is your x-axis. This is your y-axis. Here you have this graph, this piece of the graph. So you're getting closer and closer to 0. You're getting closer and closer to 0 to the origin. where does my y go? My y continues non-stop. My y keeps going to what number? To positive infinity. So it means that you have a vertical asymptote at 0. So at x equal to 0, we have a vertical asymptote. Another example. Question says, find the limit of, let's see, 1 over x as x approaches to 0. Okay, as x approaches to 0. We're not going to simply plug 0 in. We're going to take a look at the graph first. We're going to visualize this guy. What's going on? Here we have, there we go, x-axis. Then we have our y-axis. And remember the graph. The graph is like this. We have the inverse function. Then here. So when you're getting closer and closer to 0, you have two pieces of function to worry about. One piece is on the right-hand side, one piece is on the left-hand side. If you're getting closer and closer to 0 from the right-hand side, my y value goes to positive infinity. But if I go closer and closer to 0 from the left-hand side, my y goes to negative infinity. Okay. It means that I have two limits to work with. Limit of 1 over x as x approaches to 0 from the right-hand side. It's 1 over 0 with plus sign, which is positive infinity. Limit of 1 over x as x approaches to 0 from left-hand side. 1 divided by 0 from left-hand side, which is negative infinity. Again, since the limit is infinity, we're going to have a vertical asymptote. So at x equal to 0, we have a vertical asymptote.